Conservation of energy. By the end of this lesson, we'll be able to describe the translational kinetic energy of an object in terms of the object's mass and velocity, and we'll describe gravitational potential energy in terms of an object's height. We'll describe elastic potential energy and when it's appropriate to consider it. A lot of vocabulary here, as this is a new way of thinking. Oftentimes this is going to be a little bit easier than what we've done in the past, so hopefully that continues. Conservation just means all of the stuff in the beginning equals all of the stuff in the end. Energy is the ability to do work, which is measured in joules or Newton times meters, and it's used to track and predict behaviors. Gravitational potential energy, near the surface of a planet, is the potential for a planet or other planetary or massive body to drag an object towards its center. The equation is gravitational potential energy equals mass times acceleration due to gravity times the change in height. The unit is joules. Delta, remember, means final minus initial. Translational kinetic energy is the energy of motion as an object translates in either the horizontal or vertical plane. K equals 1/2 mv squared. Translational just means moving along the x-axis or the y-axis. Elastic potential energy is stored energy in an object that will return to its original shape after being deformed. Our equation for this is U sub s equals 1/2 k times delta x squared, where delta x is our spring's displacement. And the units, again, are joules. We have a couple types of energy that we're going to recognize, but not calculate anything with. One of those is thermal energy, and another is acoustic energy or sound. Mechanical energy is just the sum of all of the energies present in a situation with the exclusion of light and chemical energies. Conservation of energy, just like conservation is all of the stuff in the beginning equaling all of the stuff in the end, conservation of energy means all of the energy in the beginning has to equal all of the energy in the end. Work is the transformation of energy through the actions of a force. When a force is exerted on an object or system, then there is a change in energy that takes place. And of course, a system is the picture that we care about. To translate means to move along the x or y axis. It's helpful for this course to think of the world in terms of the x, y, and z axis. Kinetic energy is the energy of motion. If an object is translating or moving along the x or y axis, then it has translational kinetic energy. A system composed of only a single object can only have kinetic energy, and that's only if it's moving. If there is no speed, there is no kinetic energy. There it goes. When we look at the car moving along, that can be kind of difficult, so we're going to imagine that car being shrunk down to a point that doesn't take up any space. A point particle is what this is called, and that takes up no space, so there's no front, no back, no left, no right that we've got to worry about. Now we can just analyze the motion of that point particle. The equation for translational kinetic energy is K equals 1/2 mv squared, where K is our total amount of translational kinetic energy, m is our mass, and v is our velocity. This is a scalar quantity, so there is not any direction. Instead, we're only dealing with the magnitude here. A dimension is the physical quantity that is measurable, related to official measurements called units. We have standard units in physics that we use, meters, seconds, and kilograms. Those are the ones that we use in physics, but there are some others like the mole, ampere, Kelvin, and candela. We also have derived units, and derived units can be related to these standard units. Some examples include the Newton, watt, and joule. when we look at the equation, we see k equals 1/2 mv squared. Well, 1/2 has no units, but mass and velocity do. So we're going to analyze just those. So I'm removing the 1/2. Then I substitute. I see from the top that mass is measured in kilograms, so I can plug that into the equation. This is called substitution. And V is measured in meters per second. So I plug that into where V is. Remember that V is squared. It's a quantity squared. So our units are kilograms times meters per second. Meters squared per seconds squared. Remember, if an object is translating, it has translational kinetic energy. So if an object is moving, it has translational kinetic energy. There is another type of kinetic energy that we're going to deal with later on in the course called rotational kinetic energy, but right now we don't have to worry about it.